Do you know rainfall is measured in centimeters and not in liters? For an example, if you hold a glass of water, you might actually call that water to be as 100 ml. But just in case if it is going to be a rainfall, we no longer call it as liters or milliliters, we use the term centimeters. Do you know the reason why we do that? If we know the answer to this question, we can understand how much water a plant exactly needs, and just in case if we overdo it, what happens to the plant. Let's find the answer to this question in this video. Usually when we fill a glass with water, we know that the glass has a specific capacity. But however, when the rainfall reaches the ground, our ground doesn't have even surface. Our ground has a surface ranging from a steep or a flat surface or even a lot of crust. In such situation, measuring the rainfall using liters becomes a very hard job. Here is where we introduce centimeters. To accomplish this task, we have a very special device which is actually called as rain gauge. A rain gauge is a cylindrical container with a diameter of 20 centimeters. During rainfall, when we keep this rain gauge in an open environment away from trees and buildings and measure the water collected after a hour or two, we try to understand how much of rainfall we have received. And this is exactly the data which our weatherman tells during the rainfall. Do you think how this is actually linked with farming? During the growth cycle of a plant, when the plant receives excess water or if it lacks water, the plant eventually dies. This is exactly where we have to pitch in to calculate how much of water the plant requires and then instruct our robot to make sure the required water is given to the plant. And for this, let's get into a small math. Let's say a tomato plant requires 5 cm of water per week, which means the rain gauge has collected 5 cm of water in it. Now the total volume of the water in the rain gauge is pi r square h, which is the volume of the cylinder, where pi is 3.14 centimeters, r is the radius of the rain gauge, that is 10 centimeters, h is the height of the water collected, that is 5 centimeters. Multiplying these values, we get 1570 centimeter cube, which means the tomato plant requires 1570 centimeter cube per week. Then for one day, the water required is 1570 divided by 7, that is 224 centimeter cube per day. Now when we convert 224 centimeter cube to liters, we get 224 milliliters per day. Now that we know that the plant requires 250 ml of water per day, all we need to do is to communicate with our robot and make our robot understand that it has to provide 250 ml of water. Any idea how we are going to communicate this to our robot? Let's find it out in our next video.